Humanity has always looked up at the night sky with a sense of wonder. For thousands of years, we have gazed at the stars and planets, those distant points of light scattered across the vast, dark canvas of the universe. We told stories about them, named constellations after our heroes and myths, and dreamed of one day visiting these other worlds. This deep-seated curiosity, this innate desire to explore what lies beyond our own world, is a fundamental part of who we are. It is the same spirit that pushed our ancestors to cross oceans and explore continents. Now that same spirit is pushing us to journey into the cosmos. Among all the planets in our solar system, one has captured our imagination more than any other: Mars. The red planet is our next great destination. It is relatively close to Earth, making the journey possible with our current understanding of rocketry. Scientists believe that Mars was once a very different place, possibly with liquid water flowing on its surface, a thicker atmosphere, and conditions that might have supported life. We send rovers and orbiters to study its geology, its climate, and its potential for past or even present life. Going to Mars is not just about planting a flag. It is a scientific quest to answer one of the biggest questions of all. Are we alone in the universe? Our missions to Mars are preparing us for the day when human boots will finally touch its reddish soil. We are learning how to land heavy spacecraft, how to generate power, and how to protect astronauts from the harsh Martian environment. The information we gather from robotic explorers like the Perseverance rover helps us map out safe landing sites and identify resources, such as water ice, that could be used by future human settlers. Each successful mission is a crucial step, building the knowledge and experience needed for the monumental challenge of sending people to another planet and bringing them safely home. It is a dress rehearsal for our future as a multiplanetary species. The dream of going to Mars is about more than just scientific discovery. It is about securing the long-term survival of humanity. Life on Earth has faced extinction events before, and having a second home on another world would be the ultimate insurance policy. Establishing a human presence on Mars would be a profound achievement, a testament to our ingenuity, courage, and collaborative spirit. It would transform our perspective, reminding us that we are inhabitants of a much larger cosmic neighborhood. Mars is the first logical step in a much longer journey, a journey that will eventually take us to the stars. Once we have established a foothold on Mars, our journey into the solar system will have only just begun. The red planet will become a new base of operations, a stepping stone to even more distant and exotic destinations. The moons of the giant outer planets, Jupiter and Saturn, hold incredible promise for discovery. Moons like Europa, which is believed to have a vast liquid water ocean beneath its icy shell, could be a prime location to search for extraterrestrial life. Another fascinating world is Titan, Saturn's largest moon, which has a thick atmosphere and lakes of liquid methane on its surface. These worlds are unlike anything we have ever known. Beyond the major planets and their moons lies the asteroid belt, a vast region filled with rocky and metallic objects left over from the formation of the solar system. These asteroids are like cosmic time capsules, holding clues about the early history of our cosmic neighborhood. Mining these asteroids could provide valuable resources, such as water, metals, and minerals, which would be essential for building future space habitats and fueling missions deeper into space. Instead of launching everything from Earth, we could learn to live off the land, using the resources available to us throughout the solar system. This would make long-duration space travel far more sustainable. The outer reaches of our solar system are home to the ice giants, Uranus and Neptune, and a vast swarm of icy bodies in the Kuiper Belt, including dwarf planets like Pluto. These cold, distant worlds are shrouded in mystery. Sending probes and eventually humans to these far-flung locations would require incredible leaps in technology and endurance. The journeys would take decades, pushing the limits of what we believe is possible. Exploring these realms would give us a more complete picture of our solar system's diversity and evolution, from the fiery heart of the sun to its coldest, darkest frontiers. Ultimately, humanity's destiny may lie beyond our own solar system, among the countless stars that dot our galaxy. The nearest star to our sun, Proxima Centauri, is over 4 light-years away. Reaching it with today's technology would take tens of thousands of years. However, the idea of interstellar travel inspires us to dream big. We are already searching for Earth-like planets orbiting other stars, known as exoplanets. Finding a truly habitable world would be one of the greatest discoveries in human history, and would give us a tangible goal for our first journey to another star system. A journey that might be undertaken by future generations. The path to the stars is filled with immense challenges that we must overcome. The sheer distances involved in space travel are difficult to comprehend. A trip to Mars takes about 7 months, but a mission to the outer planets would take many years, and a journey to the nearest star is currently beyond our reach. We need to develop much faster propulsion systems, perhaps using nuclear energy, solar sails, or even more exotic concepts like fusion rockets. Without a revolution in speed, the solar system will remain a vast and mostly inaccessible place for human explorers, limiting our reach to our closest planetary neighbors. The human body is another major obstacle. Our bodies evolved to live under the specific conditions of Earth, with its gravity and protective magnetic field. In the weightlessness of space, astronauts experience bone density loss, muscle atrophy, and changes to their vision and cardiovascular systems. Furthermore, deep space is filled with dangerous cosmic radiation, which can damage DNA and increase the risk of cancer. We must develop better shielding for our spacecraft and find effective medical treatments to counteract the harmful effects of long-duration spaceflight on human health. Our biology is not yet ready for these long voyages. Technological reliability is also a critical concern. On a multi-year mission to Jupiter or beyond, there is no possibility of a quick rescue or a resupply mission from Earth. The spacecraft and all its systems must function perfectly for the entire duration of the journey. This includes life support systems that provide air and water, power generation, communication equipment, and landing systems. We need to create closed-loop life support systems that can recycle nearly 100% of all waste, turning it back into usable resources. Astronauts will need to be expert engineers and mechanics, capable of repairing anything that breaks down millions of miles from home. Finally, the psychological challenges of deep space missions are just as significant as the physical ones. Imagine being confined in a small space with a few other people for years on end, with no way to see your family or experience the familiar sights and sounds of Earth. The isolation, confinement, and constant pressure can lead to stress, conflict, and depression. We must learn more about human psychology in extreme environments and develop strategies to support the mental well-being of our astronaut crews. Selecting the right team and providing them with the tools to stay connected and motivated will be essential for the success of any future deep space expedition. Overcoming the enormous challenges of deep space exploration will require a new era of innovation and technological advancement. Scientists and engineers around the world are already working on the next generation of technologies that will take us beyond Mars. These include advanced propulsion systems that could drastically cut down travel times, artificial intelligence to help crews manage complex spacecraft systems, and robotics to perform dangerous tasks outside the ship. Innovations in three-dimensional printing could allow astronauts to manufacture their own tools and spare parts far from Earth, making missions more self-sufficient and resilient. This grand endeavor is too large and too expensive for any single nation to undertake alone. International cooperation is not just beneficial, it is essential for our future in space. The International Space Station is a shining example of what we can achieve when countries work together, sharing knowledge, resources, and costs. Future missions to the Moon, Mars, and beyond will require even greater levels of collaboration. By pooling our talents and resources, we can accelerate progress and make these ambitious goals a reality. Space exploration has the power to unite humanity under a common purpose, reminding us that we are all crew members on Spaceship Earth. Why should we embark on this difficult and expensive journey? Because exploration is woven into our DNA. It drives us to learn, to discover, and to push the boundaries of what is possible. The pursuit of these ambitious goals inspires new generations to study science, technology, engineering, and mathematics. The technologies we develop for space often lead to incredible benefits right here on Earth, from medical imaging and GPS navigation to improved solar panels and water purification systems. The quest to explore the cosmos is an investment in our own future, sparking innovation that improves life for everyone. The future of humanity lies in the stars. As we gaze up at the night sky, we are not just looking at distant points of light. We are looking at our potential destinations. The journey beyond Mars will be long and arduous, but it is a journey we must take. It is a journey that promises to answer our deepest questions about the universe and our place within it. It is a journey that will test the limits of our courage, our intelligence, and our ability to work together. And it is a journey that will ultimately define our destiny as a species, as we take our first tentative steps into the vast cosmic ocean.